Topic 6.1 Coulomb's law. There are two types of charges, namely positive and negative. Similar type charges repel each other, whereas opposite type charges attract each other. In other words, like charges repel and unlike charges attract. Coulomb's law. Magnitude of the force between 2 point charges is proportional to the magnitude of each charge, and the inverse of the square of the distance between 2 point charges. Here I would like to recall that the Newton's law of universal gravitation states that magnitude of the gravitational attraction force between 2 point masses is proportional to the magnitude of each mass and the inverse of the square of the distance between 2 point masses. Both Newton's law of universal gravitation and Coulomb's law are called inverse square laws. Mathematically, we can express Coulomb's law as follows. Let's consider 2 point charges Q1 and Q2 at r distance away from each other. Force is the mutual repulsive force between Q1 and Q2 like charges. As per Coulomb's law, F is proportional to Q1, say equation 1, and also F is proportional to Q2, say equation 2, and also F is proportional to inverse of the square of the R, say equation 3. Combining equations 1, 2, and 3, we can write like this. By introducing a proportionality constant 1 over 4 pi epsilon, we can write the Coulomb's law as this. Here, the constant epsilon is called the permittivity of the medium. By subjecting epsilon, we can derive this relationship. SI units of epsilon is therefore Coulomb squared per Newton per meter squared. Dimensions of epsilon is m minus 1, L minus 3, P to the power 4. Electric field intensity. Electric field intensity of a point in an electric field is the force per unit positive point charge on that point. Electric field is a space where there are forces acted upon on charges. Therefore, we can express electric field intensity mathematically as follows. E is a vector quantity. SI units of E is newtons per coulomb. Dimensions of E is m, L, T minus 3. Electric field lines. Electric field lines are the arrows indicating the direction of force on a point charge within an electric field. Electric field lines around a positive point charge like this. Electric field lines around a negative point charge will be like this. Electric field lines around two positive point charges will be as follows. Electric field lines around a positive point charge and negative point charge will be as follows. Electric field lines between two charged parallel plates are as follows. Field intensity at a place due to a point charge. Let the electric field force on a unit point charge at a distance r away from a point charge q be F. By Coulomb's law, we can write this relationship. By definition of electric field intensity, we can write this relationship. Combining the equations 1 and 2, we get following relationship. Graphical representation of the variation of field intensity around a positive point charge. Around a negative point charge.